Hello friends, this is lecture number 21 of complex analysis mathematical physics for BSc and MSc students, and today we're going to discuss we're going to learn how to find poles and residue of a complex function. And I'm going to explain with the help of some questions, solving some questions. I'm going to explain, okay, and those questions will be taken from HK's mathematical physics books. Okay, and this is my Insta ID. If you want to follow me, then you can follow me. This is my Insta ID, Lakhyajit 123, right? So if you are new to my channel, please subscribe the channel, hit the bell icon so that you get notified when new video will be uploaded, and also stay connected and hit the thumbs up button. Also share with your friends, inspire me to create new content for you. Okay, so now let's start. So I think I don't need to say what is pole of a function because we have already discussed in lecture 11. You have if you have watched all the previous lectures, then you should know what is pole of a function. Okay, so here we're going to discuss, and here we can learn how to find poles and residues. Okay, so all previous lectures, links of the previous lectures are already given in the description box. So if you want to watch all the videos, then you may go through. Okay, just open the description box and you're gonna have the links of the previous lectures. Okay, so I have introduced the pole of a function, a complex function, in lecture number 11. Okay, so now let's learn how to find poles. Okay, so here is the first question. Find the residue of this given function at its pole. Okay, sometime in the question maybe it is mentioned that at a particular pole, the pole may be given. Okay, so now when it is given that find the residue of this function at its poles, first our aim is to find poles of this function. So how to find that? So now you see, so solution. So let me write the given function first. The given function f of z is this. So let me copy this. This is the function, right? So here is the given function. So how to find the poles? Just equating the denominators, so with 0, right? That's how we used to find a pole. Z minus 2 into z minus 3 is equal to 0, right? Z minus 2 and z minus 3 is equal to 0. Equating the denominator with 0, we're gonna get the poles. Therefore either z minus 2 is equal to 0, or we can write z minus 3 is equal to 0, and this 2 implies z is equal to 2 and z is equal to 3. And here you see, as we have power on these two factors, power is 1, so that's why these are both simple pole. Okay, so these are simple pole. Z is equal to 2 and 3 are simple poles, or pole of order 1. You can say pole of order 1 or simple poles. So how to find residue at simple poles? So here you see, if let me write here, if z is equal to a is a simple pole of a complex function f of z, then the residue, we're going to write res, residue at z is equal to a, that's going to be given by limit z tends to a. Here we have z is equal to a, so we're going to multiply z minus a. So if you have z minus a, z is equal to minus a, then you have to multiply z plus a, right? Remember that. So now we have z plus a, so z is equal to plus a, this is positive a, so that's why z minus a should be multiplied with the function f of z, and we're going to take the limit of this product. So let me write here f of z. So this is f of z. right? So hope you have understood. Let me write it properly. Just wait. Just a second. Limit z tends to a, z minus a into f of z. So that's how we used to find a pole, residue at simple pole. Okay. And one more thing, if the function f of z is of this form, suppose phi of z, this is one function divided by another function psi of z, okay, in the p by q form, suppose. And here you see, if at z is equal to a, if suppose phi of z is equal to a, that means phi of a is 0, but psi of a, if you replace the z by a, phi of the a is suppose not equal to 0, then we can apply another we can use this, that residue at z is equal to a, phi of a by derivative of psi with respect to z of a. Okay, that's how also we can find. So this is of this form, but we though it is of this is in this form, we can apply this method as well, right? So let me use this one, first one, using limit. I'm going to show you. Okay, now you see, so how to do that here? Just wait. Residue at z is equal to 2, as this is simple pole, so it's gonna be equal to limit z tends to 2. So here we have positive 2, so we're gonna take z minus 2 into f of z. So what is the f of z here? This is the f of z, right? Let's put it here. So then if we put this here, then what we're gonna have, limit z tends to 2 and z minus 2, and f of z is this. Let me copy this, just wait. So we have to multiply this one here. So now here you can see clearly z minus 2 cancels. So what we have, just let me write here. So we have residue at z is equal to 2. Residue at z is equal to 2 is equal to limit z tends to 2, and we have z cube divided by z minus 3, right? So now as z tends to 2, let's put 2 here. 2 cube divided by 2 minus 3, that's going to be minus 8, right? That's going to be minus 8. Now let us find a pole at z is equal to 3. Okay, let's find a pole at z is equal to 3. Now let me go to the new slide. Let me copy these things. Just let me copy all these things. So here is the new slide. So these are the functions and the poles. So we have already got a residue at 2. So what we have got? We have got residue of this function at z is equal to 2. That is equal to minus 8. We have already got in the previous slide. Here you can see this is minus 8. So now let's find the residue at z is equal to, residue at z is equal to 3. This is also a simple pole, so we can apply limit z tends to 3. So we have to multiply z minus 3 with the given function. This is the given function. So with this, so here z minus 3 cancels. So what we have, limit z tends to 3 z cube divided by z minus 2. So as z tends to 3, so that's why at z, as you see, z tends to 3, that's why we're going to put z is equal to 3. So now let me do it here. So here is the residue at 3 is equal to what we have got. Just put here 3, z is equal to 3. Okay, so then what we're going to have, 3 cube divided by 3 minus 2, that's going to be 27 by 1, that means 27, right? So when you need to find the residue, if you are asked to find a residue at each poles, so these are the residues, these are the two residues at the poles of this function. And if you are asked to find only if it is mentioned that find a residue only, so then you have to add the residues. You need to find the sum of residues. Okay, so residue of this given function will be given by residue at the pole z is equal to 2 plus residue at z is equal to 3. So at z is equal to 2 we had minus 8, so let's put minus 8, and then we had get 27. So let's add these two, one is negative and another is positive, that's going to be 19 here. So this is the answer, right? So hope you have understood this. So now let us take another question. So here is the next question. Find the residue of this function at this pole, right? So here you see, first let me write the given function. So this is the given function, z square plus a square whole to the power 2, right? So here you see, if you equate the denominator with zeros, then what are you going to have? So you're going to see that z square plus z square, then again z square plus z square, a square, not z square. If you simplify this, then what you're going to have, z square plus a square is equal to 0. That implies z square minus a square, and z will be equal to, so minus a square means I square a square, so that's why you're gonna get z is equal to plus minus I a, right? Similarly, if you simplify this one else as well, now you see, here you see, if these two are same, product of these two is equal to 0, that's why from both this one is equal to 0, or if you take this one is equal to 0, then you're gonna get again z is equal to plus minus a. So you're gonna have z is equal to plus minus a, z is equal to plus minus a. So we are to find the pole, residue at this pole, z is equal to I, that means z is equal to plus IA. So z is equal to plus IA, we are getting 2, z is equal to, we are getting this plus IA twice, here and here. So that's why it's going to be pole of order 2. This is pole of order 2. Why? Because we are getting this plus IA, z is equal to plus IA and plus IA twice, right? And we are also getting minus IA and minus IA twice. So this is also order of 2, pole of order 2, and this is also pole of order 2. You can say that way. So hope you have understood this. So now, so we know how to find the pole of order n. If you don't know, then let me write the formula here. So now you see, if z is equal to pole of order n, then what to do? How to find that? Then residue at z is equal to a will be given by 1 by n minus 1 factorial derivative of n minus 1th order derivative. So here, if the order is n, then the order of the derivative should be n minus 1, right? So you have to differentiate n minus 1 times. What should be differentiated? Z. Here we are taking z plus a, so we should multiply z minus a, as it is nth order. So here it should be power should be n, then f of z at z is equal to a. That's how we used to do, right? So hope you have understood this. So let me show you, let me write it properly. Just wait, give me a second, just wait. So at z is equal to a, so here at z is equal to a. Okay, after differentiation, after differentiating this, which is within bracket, whatever be the expression, we're gonna put the z, we're gonna replace the z by a. Okay, so hope you have understood this. So now here you see, just let me do a bit of arrangement here. So let me write this one here, just wait. Now residue at z is equal to ia. Z is equal to ia. This is second order. Order is here, n is equal to 2, second order. So that's why so what gonna be the residue? That's gonna be equal to 1 by 2 minus 1 factorial. 2 minus 1 factorial. Second, this is second order, so that's why we have to use first order derivative. Okay, then z minus a, so here z minus ia, and f of z into f of z. F of z is this. Okay, just copy this one, let me paste this, just wait. Let me write here 1 by z square plus a square whole square. This is the f of z. So as this is this is order 2, so here we have to take square of this, right? Because here you see for nth order we had taken z minus a whole to the power n. So here for second order we're going to take z minus I whole square, right? And finally what we're going to put after differentiation, we're going to put z is equal to ia, right? Remember that. So now what we can do here, you see z square plus a square, which can be written as z square minus ia whole square. We can write that way, right? And as we have whole square here, just wait, and this can be written as z plus ia into z minus ia, right? Z plus ia into z minus ia, and if you square this, as we have whole square here, so whole square of this, that's going to be 1 plus ia whole square, sorry, z plus ia whole square and z minus ia whole square, right? So this denominator can be written this way. So let me clean this things, just wait. So here you see this is going to be 1, because 1 by 2 minus 1 is 1, 2 minus 1 factorial, that's going to be 1, right? Then derivative with respect to z of z minus ia whole square into just wait, let me write down here, one by 1 into, this is equal to z by z dz, d by dz, z minus ia whole square. Now this denominator can be written this way, right? Z plus ia whole square into z minus ia whole square. That's how we can write. So hope you understood this. Just wait, let me clean this. So now you see, so then after differentiation, what we're going to put, z is equal to ia, right? Now you can cancel this one and this one, right? You can cancel these two. So then what we're going to have, we're going to have residue at z is equal to ia, that's going to be equal to derivative of this z plus ia whole square, and which can be written as derivative of z plus I a whole to the power minus 2 with respect to z, right? With respect to z. So remember one thing, we are to put z is equal to I a, right? We are to put z is equal to I a. Okay, so remember that thing. So now you see, so let me just wait, let me use here curl bracket. So let me use here curl bracket. So and let me enclose these things within a square bracket and then write this one. So right, after differentiation we're going to put z is equal to Ia, right? So hope you have understood. Now let me go to a new slide. Okay, now let me copy this result. Just wait, let me copy this result. So here is the new slide. So what we have got, this is nothing but residue at z is equal to Ia. That is what we have got. Now if you differentiate it, what it gonna be? Minus 2, then z plus Ia whole to the power minus 3. If you differentiate it, you're gonna get this, z is equal to Ia, right? So here it's gonna be minus 2 into 1 by z plus Ia whole to the power 3. And let's put this value now, that is z is equal to Ia, then what you're gonna have, minus 2 Ia plus Ia whole to the power 3, right? That's what you're gonna have. Then so you're gonna have minus 2, and here it's gonna be 2 Ia whole cube. And if this is the case, then what you're gonna have, so it's gonna be equal to minus 2 by 8 I cube a cube, right? I cube a cube. Then multiply I both the numerator and denominator. Just do one thing, you can cancel this 8 by 2, then you're gonna get 4. And if you get 4, that's gonna be 1 by 4 minus 1 by 4 I cube is nothing but minus I, right? And a cube, because I cube is equal to I square into I square is minus 1 into I, that's going to be minus I, right? So then here this minus cancel. So what we can get, what we're going to get here, you see 1 by 4 I into a cube. Now if you multiply both the numerator and denominator by I, then it's going to be minus I by 4a cube, right? So this is our answer, right? So this is the pole at this is the residue at z is equal to Ia. Okay, residue, this is the residue at z is equal to Ia. So hope you have understood this. Now let's take another problem. So this is the function now, f of z. So here we need to find the residue at its poles. So function is tan of z. So how to find it? So now you see tan of z, it can be written as sin z by cos z, and here we're going to apply this formula, we're going to apply this rule, right? If the function f of z is of this form, and phi of z by psi of z, and z is equal to a is a simple pole, let me write simply this way, at z is equal to a, here suppose phi z is not equal to 0 but psi z is equal to 0. In that case, residue at z is equal to a will be given by phi a by derivative of psi z a, and z is equal to derivative of psi of z, and z is equal to a. So we're gonna differentiate this, and we're gonna put z is equal to a, right? That's how we're gonna find the residue at z is equal to a, right? So let's do that. So what going to be the poles here? Poles of this function. So how to obtain the poles? To obtain the poles, we're going to equate the denominator with 0, right? Then what is the solution, general solution for cos 0? So that is z is equal to twice n plus 1 divided by multiplied by pi by 2, where n belongs to z, means just instead of z let me write here capital I, which means integers. Okay, s is integer, right? So, or simply not s, n, or simply you can write 0 plus minus 1 comma plus minus 2 and dot dot dot, so on, right? So now you see, in that case, if you apply this method, right, first let us find the this is of this form, phi of z by psi of z. So now phi of z by psi dash of z, that means derivative of psi dash. So that's going to be equal to sine z, and derivative of cos z. Derivative of cos z is, let me write first one more step. This is cos z, and derivative of cos z is sine, right? Minus sine. Okay, that's going to be minus sine z by sine z. Okay, so if that is the case, right? So from here it is clear that these two gonna be equal to 1. If you cancel, so here it's gonna be minus 1, right? If you cancel this, that's gonna be minus 1. So therefore phi of if you take the if you take this instead of z, twice n plus 1 into pi by 2, then psi dash of twice n plus 1 pi by 2, then also it's going to be equal to minus 1, because it is these two are already cancelled, so that's why we can say this is equal to these two equal to minus 1. So now you see, therefore residue at z is equal to twice n plus 1 into pi by 2. So this is the pole of the function is given by is minus 1, right? Is minus 1. So this is the answer, right? This is the answer. So now let's take another question. Let us solve this question. Okay, after this question we're gonna solve one more problem. Okay, that's gonna be the last problem for today. And this question is not taken from HK Das book. This question was asked in BSc 4th Sem of Dibrugarh University. BSc 4th Sem exam, Dibrugarh University. Okay, in 2022. Okay, this was asked in 2022. Okay, now let us solve this. So now let me write the given function first. So this is the given function. Let me copy this. So here is the given function. Let's find the poles first. So what are the poles? Z minus 1 into z plus 1 whole square, and that's going to be equal to 0, right? Equating with 0, we're going to find the poles. Z minus 1 is equal to 0, and here we're going to get z plus 1 whole square equal to 0, and if that is the case, then you can write z plus 1 into z plus 1 is equal to 0, which is going to give you z is equal to minus 1, right? And it's going to give you z is equal to plus 1, right? So here this is simple pole, and this is second order pole, right? So now let's find the residue at the simple pole. So residue at z is equal to 1. So how to find it? So limit z tends to 1, z minus 1, f of z is nothing but this. Let me copy this function. So this is your f of z. So this is of order 1. So z minus 1 cancels, right? So then limit z tends to 1, z by z plus 1 whole square, and putting 1, what we're gonna get? 1 plus 1 whole square, that's gonna be 1 by 4, right? So that's one residue we have got. Residue at one pole we have got. Now let me find a residue at second order pole. So residue at z is equal to minus 1. So it is of order 2. So that's why what we're going to do, 1 by 2 minus 1 factorial derivative with respect to z. Just wait. And z minus 1, as the pole is minus 1, so we're going to write z plus 1, and second order, so z plus 1 whole square, then f of z is z, this is the f of z by z minus 1 into z plus 1 whole square, right? So and we are going to find a residue at z is equal to minus 1, right? That's right. So here this part cancels, right? So that's why what we're going to get, its value is 1, because factorial 1 is 1 by factorial 1, that's going to be 1, right? So that's why we're going to get ddz of z by z minus 1, and here z is equal to minus 1. So if you differentiate it using u by v rule, its derivative is equal to v derivative of u minus u derivative of v by v squared. If you use that, z minus 1 into derivative of z, that's going to be 1, right, into 1 minus, then z derivative of z minus 1, that's going to be again 1, right, by z minus 1 whole square. So that is what we have got. So hope you have understood this. So and then finally we're going to put z is equal to minus 1, right? Then if you simplify this, then what will happen? So here we're going to have z minus 1 and into 1, that's remains z minus 1. So here it is minus z, so then minus z plus z cancel. So we're going to have minus 1 here, minus 1 by z minus 1 whole square, and if you replace the z, if you replace the z by minus 1, then what are you going to get? So you're going to have minus 1 by minus 1 whole square, that's going to be minus 1 by 4. So that is minus 1 by 4. Its value is going to be equal to 1 by minus 4. Okay, minus 1 by 4 or minus 1. So residue at these two poles, we have got the residues at the poles, and that is plus 1 by 4 and minus 1 by 4. Then if you find a residue of this function, that means you have to sum of the residues of the poles. You have to take sum of the residues of the residues of the function at its poles. So that's going to be, so residue of f of z, that means the given function, is residue at z is equal to, the simple pole was 1, and residue at z is equal to minus 1, which was of order 2. So at z is equal to 1, what we have got? We have got 1 by 4, right? And z is equal to minus 1. Here we have got minus 1 by 4. So here it's going to be plus 1 by 4, then plus minus 1 by 4, and these two gonna cancel each other, so it's gonna give you 0. So this is your answer. So hope you have understood. Now let me take one more question, last question. Okay, now you see we have already learned that residue at z is equal to a, suppose, which is nth order. If suppose z is equal to a is nth order pole, then residue at this is equal to 1 by n minus 1 factorial n minus 1 order derivative with respect to z of z minus a whole to the power n f of z at z is equal to a, right? We have got that. So if you have to find a residue at second order pole, then you have to put n is equal to 2, right? For third order pole you have to put n is equal to 3, so that means you have to differentiate twice. And if the order is 2, then you have to differentiate this once. And if the order is 5, 6, then what are you gonna do? You're gonna differentiate 5, 6 times. So instead of doing that, we're gonna apply another method. So what is the method? So let me write that one. So here you see, so residue at pole of any order, residue at a pole of any order. It may be simple pole, second order, third order, fourth order, and so on. So at any pole, that is, suppose what rule we're going to follow, that first put z is equal to a, simply you can say z minus a. If z is equal to a is the pole, then z minus a should be is equal to t. We're going to put z minus a is equal to t, which implies z is equal to t plus a, right? So then where we're going to put in the function f of z, right? In the function f of z. Then next step, we're going to expand what the function after replacing z by t plus a or a plus t. Okay, so in the powers of t, then the coefficient of 1 by t, the coefficient of 1 by t, the term containing 1 by t, what will be the coefficient of this? That's going to be the residue. That's going to be the residue at z is equal to a, right? So now let me give you an example. So here is the question. Suppose find the residue of this function. We have, suppose, z cube divided by z minus 1 whole to the power 4 and z minus 2 and z minus 3, right? At z is equal to 1, right? So it is very clear. You see z is equal to 1. So here z minus 1 whole to the power 4, that is the pole of order 4, right? So here the given function is f of z. The given function is this. So here is the given function. Just let me copy this. So here you see this is the given function, and if you equate the denominator with zeros, then you're gonna get z minus 1 whole to the power 4 is equal to 0. So from here we're gonna get z is equal to 1 1 1 1. That's gonna be order 4, right? Order is 4. So if the order is 4, then if we apply this rule 1 by 4 minus 1 factorial, right, we have to differentiate 3 times 4 minus 1, right? So instead of doing that, we're gonna apply the rule that I have mentioned here, this. So how to do that? Now you see here, just first step is to put, let us put z is equal to z minus a. Here a is 1, okay, z minus 1 is equal to 2, who is going to imply z is equal to t plus 1. Z is equal to t plus 1, right? So, or you can say 1 plus t plus 1, same thing. So now let me write 1 plus t here. So now let's put here 1 plus f of 1 plus t, that's going to be equal to 1 plus t whole cube, then divided by z minus 1 is t, so it's going to be t to the power 4, and z minus 2, instead of z minus 2, if you put 1 plus t then minus 2, that's going to be t minus 1, right? That's going to be t minus 1, so t minus 1, and if you put here 1 plus t, then it's going to be t minus 2, right? That's what we're going to have, right? So now you see it can be written in this way: 1 by t to the power 4, 1 by t to the power 4. If you cube it, that means if you find apply the whole cube formula, that's going to be t cube plus thrice t square plus 3t plus 1, and we can expand it this way: t minus 1 whole to the power minus 1. Here we're going to apply the binomial theorem, right? So, and this can be written as t minus 2 whole to the power minus 1. Now what we're going to do, we're going to take minus 1 common from here and minus 2 common from here, and doing that, what we're going to get, so we're going to have f of 1 plus t, that's going to be equal to 1 by t to the power 4, 1 by t to the power 4, and here you see, just do one more thing. If you just do one thing, let us take minus 2 and minus 1 common from these two, then minus 1 by 2 and here you see minus 1 by 2 and minus 1, that's going to be plus 1 by 2, right? And if you multiply this t to the power 4 with this, then what you're going to have, you're going to have 1 by t plus 3 into 1 by t square, then plus 3 into 1 by t cube, then plus 1 by t to the power 4. That's what you're going to have, right? So let me write it properly. Just wait. Okay, just wait. Let me go to the new slide. Let me copy this. Just wait. Let me copy these things and let me go to the new slide. So here f of 1 plus t. So now what we have done, we have taken minus half and plus 1, minus 1 taken common, minus 1 and minus half taken common, and given both gives plus half, right? And just multiply 1 by 4 with this, then you're gonna have 1 by t plus 3 by t square, then plus 3 by t cube, then plus 1 by t to the power 4. That's what you're gonna have. Then here we're gonna get 1 minus t to the power minus 1, and here we're gonna get 1 minus t by 2 whole to the power minus 1. That's what we're gonna have, right? So now we are going to expand this using this formula, 1 minus x whole to the power minus 1, that's gonna give you 1 plus x, then plus x square plus dot 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 so on up to nth term, right? So if you apply that, what you're going to have, 1 by 2, 1 by t plus 3 by t square plus 3 by t cube, then plus 1 by t to the power 4. So expanding this, what we're going to get, 1 plus t square plus t cube plus dot 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 so on, and let us expand it. Then you're going to have 1 by t by 2 plus 1 plus t by 2 and t square by 4 plus t cube by 8 plus dot 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 so on. That's what we're going to have. So now what we can do here, you can see that, so here you see we have to keep one thing in mind, that we need to find a coefficient of 1 by t, right? So now you see, if you multiply these things by 1, then you're gonna get 1 plus t by 2 plus t square by 4 plus t cube by 8. We don't need the extra next term, t to the power 4 by something, whatever we're gonna get, because here you see maximum power on t is t to the power 4. So you're gonna get 1 by t when you're gonna multiply 1 by t to the power 4 with t to the power cube, t to the power 3, right? Then only you can get 1 by t. As we need 1 by coefficient of 1 by t is, so that's why we are not going to take any other term which have such that the power on t is greater than 3. That is, suppose 4, then you're gonna get, these two will be cancelled, but here we're gonna get 1, but we need 1 by t, right? So that's why we're gonna stop here wherever we're gonna get t to the power 3. Okay, then multiply this with multiply this by this t, right? And then what you're gonna have, if you multiply this by t, then you're gonna have t plus t square by 2, then plus t cube by 4 plus dot. We don't need to get the t to the power 4 terms. So similarly, if you multiply this by t to the power 2, then what you're gonna have? Then you're gonna have t square plus t to the power 3 by 2. Then we don't need more. Then if you multiply this with this by t to the power 3, then we're gonna get the first term t to the power 3, and we don't need higher power. Okay, so now what if just do one thing, just add up all these terms. So here 1, then t by 2. Is there any other t by 2? No. Or any term t? Yes, this is t. So these two are like terms. If you add t and t by 2, then what you're gonna get? You're gonna get 3 by 2 into t, right? Plus, then adding terms containing t square, we're gonna get, this is t square, not this one. We're gonna get 7t square by 4. Then similarly, we're gonna have 15t cube by 8. If you add this one, and this one, then you're gonna get 15t cube by 8. Okay, so now let's stop here. Let me clean these things. Okay, so then plus dot, we're gonna get more terms, right? So this one into this. So now the result becomes this. So now let's multiply these things here, and you see we need the coefficient of 1 by t only. So 1 by 2. So first check the terms. So where you gonna get the 1 by t only, right? So now you see, if you multiply 1 by t with 1, then you're gonna get 1 by t, right? 1 by t, right? Then if you multiply 1 by t with this 3 by t, you are not going to get 1 by t. So just leave it. Now if you multiply this one with this, then what you're gonna get? 9 by 2, and you're gonna get 9 by 2 into 1 by t, right? If you multiply this one with this, right? So hope you have understood. This is plus. Then if you multiply this one with this, then you're gonna get 3 7s are 21 by 4, 21 by 4, 21 by 4, 1 by t, 1 by t, right? So then if you multiply this one with this, then you're gonna get 15 by 8, 1 by t, 15 by 8, 1 by t. And we're gonna get more terms after this, but there we are not, those terms doesn't contain 1 by t. Okay, the remaining terms will not contain 1 by t. So now let us take 1 by t common. So here you're going to get 1 plus 9 by 2 plus 21 by 4 plus 15 by 8. So if you take 1 by t common, then what you're going to get, right? So here you see the coefficient of 1 by t is this. So this is the coefficient of 1 by t. So now let me copy these things and let me go to the new slide. Here you see. So what we have got f of 1 plus t is equal to this, right? This is what we have got. Therefore residue at z is equal to 1, which is of order 4, is coefficient of 1 by t, and which is equal to half into 1 plus 9 by 2 plus 21 by 4 plus 15 by 8, 15 by 8, and then if you multiply by 1 by 2 plus 9 by 4 plus 21 by 8 plus 15 by 16. So taking LCM, we're going to get 16 here, then it's going to be 8, then it should be 36, right? 36, then here 2 times of 8 is 16, so that's why 42 into this, and this is going to be 15, right? So if you all add all this, then 42 plus 8, that's going to be 50, and then 50, and 36 plus 15, that's going to be 51, right? So 101 by 16. So this is our answer. So what is the answer? 101 by 16. So hope you have understood this. So see you in the next video. Thank you for watching, and share with your friends, subscribe the channel, hit the thumbs up button if you like my videos, and stay connected. Bye bye.